Hi, I'm Saurabh Singh. I'm a faculty member at Raman Research Institute, and we are a part of CMB Distortion Lab doing experimental cosmology. So with our experiments, we are trying to probe the very early part of the universe when it was infant and trying to understand the nature of the first stars and galaxies that were formed as the first generation. So how different they were compared to when we see all the stars and galaxies around us today, and what impact their formation had on the universe as a whole. So the way we are trying to understand this is by observing a very unique signature emitted from hydrogen atoms. However, the signal is coming from very distant past, and therefore it is extremely faint to detect. Therefore, we have to build our experiments which can be calibrated to very high accuracy so that we can separate everything else from this very faint signal from the first stars and galaxies. And not only that, when we conduct these experiments out in different locations, we also have to tackle other challenges. One of the primary challenge is interference. So at these operations, at the range of frequencies that we have our instruments in, we have a lot of terrestrial interference coming from different sources like FM, TV stations, the flights. Last but not the least, also from our own electronics.
I'm Mayuri Rao. I'm a faculty member in the astronomy area at the Raman Research Institute. Most of the experiments we build operate at radio frequencies. They are very, very sensitive radio telescopes. One set of experiments operate in the about 100 megahertz frequency range, where we have a lot of radio frequency interference from things like FM radio and communications. So while our experiment can go to radio quiet locations, it is very important that our own instrument's antenna does not pick up electronics from its own receiver electronics. So for this, we have a very high requirement on the level of EMI suppression, which is where this kind of a box comes in handy for us. So RF Electronics has provided us with this excellent box, which houses our receiver electronics in two trays. And our antenna sits right on top of this box, so that even any radio frequency interference or self-generated EMI that comes from this electronics placed right below the antenna does not get picked back up by the antenna and feed into our data. So the kind of requirement we had for this experiment was about shielding of 120 dB or higher in the frequency range of operation of 55 to 110 megahertz. Previously, we had our electronics in a simple aluminum box that is not quite an EMI enclosure. And of course, we were seeing a lot of self-generated EMI in our data. And this box we have tested, and we have, to the test measurement capability, we have seen it is providing a suppression of 100 dB or better at 100 megahertz. And that has been a big factor of improvement in our experiments.
And this is very crucial for different applications that we have, because one of our experiments is actually space-based, where unlike ground experiments where we can separate our electronics from our detector, which is basically the radio antenna, here everything has to be together. So even a slightest amount of leakage from these electronics can be very readily picked up by the antenna.
In general, overall, we've been very happy with the quality of the build. A lot of nice thought has gone into it. We also have things we did not expect in the box, including a nice way to lock the box, and for safety of these electronics that could be operating in remote conditions, not attended very frequently. So it keeps the instruments inside safe. We have really nice fans, connectors. So soon we'll be putting our antenna on top of the box, connecting the data in remote locations and going for the science goal we're looking for.